All right, let's take a quick peek at lesson 4 in unit 6. We have talked about tape diagrams, but now we're going to start focusing on the equations that are associated with tape diagrams, because let's face it, eventually we are going to see that it's much more efficient to just use an equation than have to draw tape diagrams. It's a lot less time, and once you get better at it, you'll save yourself a lot of time. So if you look at the learning targets, it says I can draw a tape diagram to represent a situation where there is a known amount. Let me get to red here. And several copies of an unknown amount. In other words, X. And then explain. So you've been doing this, and then I can find a solution to an equation by reasoning about the tape diagram. So we're going to be looking at equations in the tape diagram. We're going to notice they are very, very similar, and eventually we won't need the tape diagram, but first off, we have to learn what the equations look like in order before we can solve them, and the tape diagrams help us do that. So the warm-up says find a solution to each equation without writing anything down. So I think you can do this one, so go ahead and do that. And this one, if you remember from yesterday, if I have a parentheses, for example, 2 parentheses 5, that means 2 times 5, which is 10, 2 parentheses 5. So this is kind of like saying 2 times, I shouldn't use X, 2 times something equals 10. Well, we know what this bracket must be. This X plus 1 must be 5, because I just kind of did it right here. We know it's 5. So what, if all of that, if X plus 1 equals 5, then what must X be so that it equals 5? I think you can make that guess. So the next two are the same way. It's kind of like saying 3 times something equals 15. Well, we know that something is 5, so what must X be? And here they just reverse the order and put the equal amount on one side, and then it's over here. So 100 times what equals 500? And so what must X be so that those parentheses equals 100? I know 100 times 5 is that, so what must that X be? And you'll notice all of them except the first one equaled, no, I'm sorry, all of them should have equaled the same number. So we're going to dive into that. So these parentheses are what we really need to learn right here on what they mean. Parentheses mean multiply, and not always is it just a number. Sometimes we can have a variable, a letter in there. So first off, to make more sense of this, let's practice drawing some more tape diagrams with some situations. It says for some situations, you need to decide what to represent with a variable, meaning if we don't know what it is, we just make it up. In this case, you can see they said use X. In this case, they said use X. So it says Diego has 7 packs of markers. Each pack has X markers in it. After Lynn gives him 9 more markers, he has a total of 30. So there's my tape diagram. 7 packs of markers with X markers in it. So there's 1, 2, 3, 4, 5, 6, 7. And then he gave me 9 more markers. And there's that additional 9. And all together, that equaled 30 markers. So that's how A looks like. Let's look at B. Elena is cutting a 30-foot piece of ribbon for a craft project. So sounds like that tape diagram is just that, a tape of ribbon. She cuts off 7 feet, then cuts the remaining piece into 9 equal lengths of X feet each. So what do you think that's going to look like? I'm going to let you finish that one on your own, but I will tell you the whole thing sounds like it's 30. So 7 feet gets cut off, and the rest is 9 equal lengths of x feet. Going to look somewhat similar to A, except not exact. All right, I'll let you try that one out. Let's look at C. A construction manager weighs a bundle of 9 identical bricks and a 7-pound concrete block. So 9 identical. We don't know what each one is. The bundle weighs 30 pounds. So again, all together, that whole thing is going to be 30, just like just like B and just like A. 9 identical bricks and 7 pounds. We don't know what each brick is. Believe it or not, C, if you want to hit pause and see if you can figure that out. But C is going to look identical to B. Identical to B. So if you looked at B and you said, wait a second, there's 9 equal lengths, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there's 7 feet that gets cut off, and the rest is remain. Guess what? C is the exact same picture. Each brick is X. We don't know what it is. We can call it B if we wanted to. It doesn't have to be X. Plus 7, all that will equal 30. So believe it or not, you draw the same thing for C as you did for B. D says a skating rink charges a group rate of $9 plus a fee to rent each pair of skates. A family rents 7 pairs of skates and pays a total of $30. So let's start with our tape diagram. A skating rink charges $9 plus, so it's gonna be $9. There it is. Plus 7 pairs of skates. We don't know what they charge per skate. So, pair of skates, 2, 3, 4, 5, 6, 7. And what's all that equal? You should draw that wiggly mark just like we did up in B. All that's going to equal $30. So draw that wiggly line and make all that equal to 30. And there you'd have it. So it's $9 plus 7 fees for skates. And finally, this one's a doozy, kind of annoying. I want to skip it, but let's go ahead and look at it because this one's different than all the others. It says, Andre bakes 9 pans of brownies. He donates 7 pans to the school bake sale and keeps the rest to divide equally among 30 students. So this is relatively annoying, but I'm going to let you know. I'm going to take a shortcut because let's face it. If he divided it among 30 students, then we technically need 30 X's or 30 S's or whatever we want to use students. But this one's kind of weird. There's a total of 9 pans of brownies. 7 of them, so 7 would be about that amount. 7 of them get donated, which means the rest the students get. Unfortunately, we got to split this 30 ways, so I'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I would need to make that, so I'm going to save my life. Here's a little shortcut. Instead of drawing 30 X's, guess what I can do? I can just write 30X. It's a little bit of a shortcut. I kind of cheated, but technically I needed 30 X's, and I just don't feel like slicing that into 30 pieces because that would look sloppy, unless I drew it really big. So 30 students, as you can probably guess how you're going to solve this is, 30 students get to share two pans, meaning we're going to split two pans 30 ways, meaning we'll get to know each person gets 1/15 or 2/30 of a pan. But we'll look at this next section. Activity 2 says, okay, we just drew a bunch of really good diagrams. So it says each situation in the previous activity is represented by one of these equations. Here's an equation, here's an equation, here's an equation. Match each situation to an equation. And then find a solution to each equation. Use your diagrams to help you reason. And what does each solution tell you about its situation? So let's look at this first one. A, what does that look like? Well, 1, 2, 3, 4, 5, 6, 7 x's. I see 7 x's and I see a 9. So guess what? 7 x's plus a 9 is equal to 30. So what would we do first? It said, so that's step 1. Match, check. Well, at least we did that for the first one. Find a solution to each equation. And then what does that tell us? When we find out what 1x equals, so we had 7 packs of markers, 7 times however many are in each pack. After Lynn gives him 9 more, he has a total of 30 markers. So, first thing, if you're looking here, let's get rid of this 9, right? Let's take off 9 from this 30. That means 7 packs of markers, 7 times however many are in each marker, gives us 21. So now it's kind of like saying 7 times what is 21? And you might go, oh, x equals 3. I always like to circle once we know what x equals. That's part 2. We solved it, right? Part 2 down here says we matched it. We found a solution. Now we need to say, what does that even mean? X equals 3. So what? What does that even mean? We need to write it, and maybe we'll write it up here. So what does that mean? 3 is what? The number of pillows on the bed, the number of people getting on a boat. Well, in this case, it's not just 3 markers. It's how many, each pack has X markers in it. Let's replace X with 3. Each pack has 3 markers. So we can even write that. Or we can just say 3 markers per pack. And now I'm finally done with, I'm going to draw a wiggly line so that I can keep this separated. I'm done with A. Now we need to do the same for B, C, D, and E. So we can see the ones that had 7 x's, this equation must go with it, right? The ones that have 9 x's in our tape diagram, that equation must go with it. And then there's only one equation that had 30 x's, and you guessed it, that probably goes with this one right here, with that one right there. So, guess what? If we know, we don't really need to, since we already did this equation, since we already did it with this one, anytime we see that same equation down here, we don't really need to solve it. We already know what it is, right? We need to, though, this is going to change right here. This part right here is going to change for each problem. But anyway, we had 7x plus 9, right? So here's also the 7x plus 9 equals 30. We already know that. We already solved it and found x equals 3. But you need to tell me, what is the 3? 3 does not mean the number of markers in this case. Number of markers, don't write that, because this has nothing to do with markers. So what does that x equal, right? On this one, we can see there are 9 x's plus 7. All that's 30. So what would the first step be? Well, let's get rid of 7. And then we'd have 9x equals 23, which is really annoying. but so be it. And that means x equals, I got to take 23 and split it 9 ways. So I could just leave it like that. I could also say that that's equal to 9 goes into 23 twice, with the remainder of, that's 18 plus 5/9. That's an annoying number, but so be it. So x equals 5/9. Well, guess what? That works for this problem. And you'll notice that's the same answer for C. B and C, but each B, 2 and 5/9 means something way different than C. So you need to write somewhere, like maybe right here and maybe over here. X means what? X stands for, or X means, I'm going to leave it up to you. What does each solution tell you about? So what is 2 and 5/9? It's way different for C, and it's way different for D. And on this one, 30x plus 7 equals 9. So if I got rid of these 7 brownies, or pans, I'm left with 2 pans, right? If I got rid of that 7, it says plus 7, so the additive inverse is minus 7. That means 30 kids get to share 2 pans. That makes sense. You gave 9 pans, 7 gets donated, the rest, meaning 2 pans is left over. So guess what? We're going to take 2 pans and split it 30 ways, and that's what x equals. You could leave it like that, or we could simplify this since both the denominator and the numerator can be divided by 2. But what does that mean? 1/15. 30 students, x stands for what? What does that mean? Well, that's the amount. Or we could say each student gets 1/15 of a pan. So, if you look at lesson 4, don't worry about doing number 1 right now. Number 2 should be pretty simple. That's just a review. What's a negative times a negative? What's a positive times a positive? Or negative times a positive. There aren't. So you can just stand it there. But problem 3 is kind of just like we just did. There's 3 stories, 1, 2, 3, and 3 equations, 1, 2, 3. Each equation goes with a different story. Decide which equation. If you think this one goes to that one, great, draw a line there, but I don't think that's correct. Just quickly to find a solution. So try to do what we just did, and then again, what does each solution tell you about that? And then do number 4, and 5 won't take you very long. Number 4 is just the same thing. Find a solution. X equals what? That's kind of says find a solution to the equation and explain your reasoning. How would you find what x equals in this case? All right, we're going to call it good there for now. As usual, come see me if you have questions or concerns, but that's about all she wrote. All right, peace.